Hey Matt, how you doing?
How's it going?
Doing great. I hear this story. We're going to talk about the infamous problem of donning and doffing, putting on, taking
Yeah.
off exoskeletons.
Yeah. First I don't know what you were like, but for me, when I first got involved in this type of tech, and somebody started to talk about donning and off doffing, and I'm kind of like,
What the heck's that, right?
yeah, and who cares?
Oh
So
yeah,
what?
who cares? Exactly. It's not a big deal, right?
You can't like take it on, take it off. You take your shoes off every night.
Yeah.
What's wrong with you people?
Right.
But yeah, it's one of the hottest things I ever hear
Yeah.
talked about. In
It
fact,
is. It is
this week
super
it was
serious
one of the
too. Yeah.
hmm
Yeah. We.
So you kind of go, this is such a huge thing to talk about. Where do we even start?
Well, I remember. It was a few years ago when we did the first couple of exo games where we had students build exos and test them out using standard test methods. And like one of the hard things for them to do was donning and doffing, putting on and taking off an exoskeleton, and entering into like a vehicle surface, a vehicle compartment or something like that, opening the door and all that. So all that kind of maneuvering stuff. So I got to see that kind of firsthand. And I've also put on and taken off a lot of different exoskeletons. And I can tell you, it can be a bit confusing. And you need like help that first time you're doing it because you're like, where does this thing kind of go? For a lot of cases. Has it been
Mhm.
like that for you too?
Yeah, yeah. So it was interesting from an early days of when we did. So for anybody who doesn't know, I used to work within a university sector as well, and we designed lots of exoskeletons. Now, the first one we'd ever made, we were so excited about it. We called it Marsha. We
Oh
were
yeah,
so excited.
it
We
was
kind
good.
of thought, oh my God, we kind of thought we cured it all.
Yeah.
Pave the way.
Yeah,
Just
it's
call,
nothing's
just
gonna get better than this.
yeah. And then you kind of look at it and go, what did we do?
Yeah.
But what was interesting with it is we thought about it and then we realized, how do you get it on
Yeah.
and how do you put it on? And then posed to be the problem is once you figured out a way to get it on someone's body and hold it on, you end up with I mean, for us, I think we had something like 11 straps on just one limb.
Right.
And you got to think that's like strap, strap, strap,
Oh,
strap.
yeah.
And then somebody said to me, "Well, where if you need to go to the bathroom?" And you go,
Oh my gosh, yeah.
"Oh my gosh, this is a real problem,
Yeah.
huge problem."
Oh, yeah.
And I kind of thought, "Yeah, these people who do the soft exoskeletons, they must find it dead easy." Oh
No.
no,
No.
oh
No.
no,
Yeah.
no, not at all.
Yeah, and it's with a passive exoskeleton, it's even more important that you have good attachment on there too.
Yeah. So our friend Tan in on the O2 side
Yeah.
for who does fit and accommodation
Yep, the
for the
human
human
factor stuff.
the human factors side. He tells us an awful lot about something that doesn't fit quite right,
Mm,
the impact on somebody's body whilst it not fitting. And I know that's a little bit a tangent to what we're talking about here, which is the donning and doffing. But you've got to think if you don't get that attachment just right, it doesn't fit right. If it doesn't
right.
fit right, it doesn't function. So you've got to try and find the minimum level of fixtures, but maximize the way of that you're interfacing with the human body.
Yep. Yeah, and
And
the other thing you make me think about, Matt, it's like, it's that time of year where, I call the place we live affectionately crematoria because it's so hot and the sun is beating down all the time. And one of the things that thinks gets into your mind is, okay, if this is going to take me a long time to put on, don, or take off, doff, and it's hot outside, I may just choose not to use this thing. And that gets to
yeah.
like the adoption issue, not just the fitting and performance issue.
So this week we launched one of our early days pieces, a if you will, an early stage prototype piece that we've
Right.
been working on. And it's super exciting event. We had a lot of representation from all different walks of life throughout government and right across.
Nice.
One of the senior position guys comes up and he says, "I love what you got. It looks amazing." He said, "But when you go, here
But
we go."
here we go.
And he says to me, he said, if I'm gonna go and pick something up that's in the back of a truck, that's say 40 pounds, 50 pounds, or whatever,
Right.
just to minimize it. And he said to then I've got to go and get the device, put it on my body, strap it on, then walk over, pick up the device, walk back over, and then put it down, unstrap it all, and take it back off. And he's saying, I'll be honest, I ain't doing that. I'm
Right.
just gonna go and pick it up and injure myself.
Yeah.
And you go, that adoption element becomes quite heavily into play, doesn't it?
Yeah. Yeah. And it's like, is the juice worth the squeeze? For a singular type event like that, it's got to be so easy that you just wouldn't want to do it without it. But if you've got something where it's a long-term type thing or a very repetitive event, then it becomes a little bit more, I think, palatable to take a little bit longer to put on or take off. To me, it's very dependent on the situation too.
Yeah, now this is what you see after this had happened, and it came. We walked. I walked away with a million ideas about it. After this had happened, it made me think of some of the conversations that we'd heard at the Exo Games from
Right.
David,
Right.
uh, and when he talked about his experience working with the Department of Defense,
Yep.
and they were talking very particular about that, where they were saying the exoskeletons they'd looked at was fabulous. They were really good, but for what they've been designed for.
Right.
And it's the key thing, isn't it?
Yeah.
Everybody I've spoken to so far who's, and again, I know it's slight tangent, but everybody I've spoken to so far who's really started to make a dent in the exoskeleton world, what they kind of did is they stood back and they just focused on a task
Yes.
rather than trying to solve the
Everything.
entirety of biomechanics.
Right.
And it does instantly get you to thinking about keeping that focus about what the task is for. So what is it that you're supporting in that action?
Exactly. Yeah, and that, I would agree with that. I think that's been a successful strategy for multiple companies, which is focusing on a very particular task, a very particular type situation. Because, like you said, when you start trying to set up an exoskeleton to cover all possibilities, it doesn't do very well in a lot of them. You know,
Yeah.
it does okay in most, but it doesn't do very well in a lot. And that comes to that gets to, well, is it worth putting on? Is it, all of those other questions come up.
Yeah, it's the whole peanut butter term, isn't it? You can't spread it on everything. It just doesn't work.
Right. And we talk about this because exoskeletons are it's wearable technology, which in a sense, everything you wear is kind of personal in a way. It's like the watch you wear, the shirt you wear, the shoes you wear. They need to, you know, they need to conform. They need to fit well, and for a lot of people, they need to represent well. And so I think exoskeletons are very similar to that. It's like every other piece of wearable gear. It's like, okay, it needs to fit very well for the situation I'm in. I use the example all the time. Motorcycle gear. I you know, oh my god, the first time I was putting on like real motorcycle gear, I was like, "Oh lord, I don't know if I'm going to fit in this." And I certainly can't move very well. And everybody's like, "Oh no, no, it'll be fine once you get on the bike." I'm like, dude, I don't know if I can walk over to the bike right now. This is a bit tight. I'm not used to clothes like hugging
Yeah.
me, like squeezing me like juice. And and they were right. Eventually, yes, I realized they were right. Like when you're on the bike, it works great, but you don't want to walk half a mile in that gear either. That would not be the most comfortable thing to wear.
Yeah, that's right. That's right. So, um, that's a key element to it, though, isn't it?
Yeah.
making sure that it conforms, making sure that it complements what you wanted it to do. But the question is, and I've been racking my brain with this ever since I had this conversation with them. Do you design an EXO that should be worn for the day, or do
Right.
you design an EXO that should be used for a task and then taken off?
Oh, you are now digging into deep water here, which is which gets down to, you're getting down to like the key questions, some of the fundamental issues. What is an exoskeleton? It's really what you're driving toward, and it could be even you can narrow that a little bit down as what is this exoskeleton? I'll use some terms we throw around all the time. Is this exoskeleton a tool? Okay, if you think of it as a tool, I can definitely design and think of it for the task the tool is meant for. It's very task oriented. But if I
Mhm.
if I say this exoskeleton is supposed to be personal protective equipment or something similar to that, then okay, this is an all day thing and it needs to be flexible to handle all the situations that this type of worker or whatever is going to experience. Those are two different design paradigms.
Agreed. But then you get into that very vicious area. If you get to PPE, then you've got a doffing time. You've got to
Absolutely.
get that kid off. It's is it something like 60 seconds for some places?
Yeah, it's like, it gets down to self-evacuation time is what it gets down to. Everything tends to be based off of that. So if you can, and depending on the building and the situation, but let's
Yeah,
say, you can self-evacuate out of a building in, 90 seconds or whatever it may be. Um, if that exoskeleton adds time to whatever that figure is, whether it's 90 seconds or 3 minutes or whatever it is, then it's a problem. And you better be able to show that that exoskeleton or any other piece of equipment can be doffed rapidly. Like there's some sort of emergency pull on it where it falls off or something,
yeah,
and it
yeah.
doesn't change that time. Or you can wear it and self evacuate within the mandated time. That's kind of how that plays. It all depends on like the local fire codes and those kind of things. Or especially if you're in a occupational setting, say you're in a hazardous environment, that time frame may be different depending on those things. But in general, it's usually around the fire codes. And if the any kind of wearable, not just if any wearable changes your ability to evacuate, it is going to be either okay if you can't get it off in the right amount of time, and it's going to make you not be able to evacuate in the right amount of time. You may not be able to use it. So you've got to
Yeah.
design something where it would fit the scenario. If that makes if that kind of puts it
Yeah,
in a
no, no.
nutshell.
Yeah, that fits it quite nicely because it then you then get to the point of that surely the biggest doffing elements of what we're talking about tend to be professionally focused.
Yeah.
So like the likes of first responders right through to military applications. Um,
I
I mean,
mean, there is a consumer element to it. So say, there's a situation where, again, it sort of ties in with what you were talking about a little bit with first responders. So say you're in
yes,
a consumer exoskeleton, you bought it off, Walmart, Amazon, whatever you buy it from,
yeah,
and you're wearing it in a car, or you're wearing it on a bicycle, or you're just walking around and you have an emergency, some sort of accident, whatever, and responders come to help you and they have to get it off of you. That's
mm,
a non-self doffing situation, but it's an emergency doffing situation. And so now you need the responders to have the right information to be able to get it off of you safely. That's a different kind of scenario, and that would cover across any scenario, whether it's consumer or
yeah.
occupational.
Yeah, because I presume, I mean, just staying on that line, I presume that the likes of body armor for motorcycle body armor, I
Sure.
presume that sits onto the same boat of where they need to be able to just cut it off your body.
Oh yeah, they would cut it off. Like with motorcycle helmets, most of them have because the big thing is, most of the helmets are fitted fairly snugly.
Yeah.
and it has a chin strap. And so they will have majority of them have a little red tab along that chin strap where it's an emergency pull tab, and it will completely open that chin strap up right away so that someone, not the rider,
Get
could get
access.
that helmet off in an emergency
Yeah.
situation.
Yeah. I mean, I've not had an awful lot to do with motorcycles, so it's almost an education just in that conversation.
But it's very much, any kind of thing, whether you're bicycling, motorcycle, riding horses, you all have, it's very similar types of gear. You have some sort of shoe, you have some sort of pants, shirt, vest, those kind of things, and a helmet. Those kind of situation, that could be everything from sports to construction to whatever. You know,
Yeah.
if you have an emergency situation and you're wearing something, in this case, because exoskeleton is such an emerging technology, responders may not have seen this before. So that's what makes it a little bit more special than if you were just wearing like a motorcycle helmet.
Yeah. Yeah. Yeah, I mean it's interesting. So the groups that I spoke to yesterday, they were really concerned on the idea of did they need to wear it all day?
Right.
The process of did they need to wear it all day? And of course I said, no, no, of course you don't need to. And they said, well, if I'm wearing the rest of my kit, where
Right.
does it go?
Where does it go? Yeah.
Yeah. So then that's when you get to the point of do you design it to be worn all day or do you not design it to be worn all day? What's the best better way of being able to take that method of approach? I mean, their real thing was they wanted to be able to get it off when they wanted to.
Right.
They didn't want to have to leave it on.
Yep. And it's
So
about convenience. So, back to the motorcycle analogy. So I used to ride my motorcycle to work every day at the lab I worked at. And, I had the big thing that drove a lot a lot of things was I had boots and motorcycle boots. They're great on the bike, but they are not the most comfortable thing in the world to walk around with all day. So, what that would drive me to do would be is like I would have a pair of regular shoes at my workplace that I would change into. Beginning of the day, and then at the end of the day, I'd change back. And so, you know, that's another way to approach these things. Everybody's been thinking about with the exoskeleton, and I know we've talked a little bit about this in the past, is an exoskeleton's all one big piece. Well, yes and no. That's a design decision. Exoskeletons can be modular. There could be parts of it. Hey, I can take this off. I don't need to take the whole thing off, but I can take this off. This part that's inconvenient for me to be walking around in all day, and then I can put it back on when I need it to go home or whatever, whatever the case may be. So I think there's design approaches where you can even deal with that situation.
yeah, I mean, it always takes me back to as a child, watching the cartoon characters, Centurions. Now, not everybody seems to know them, so if anybody watches this and you remember what I'm saying, please do comment. It was an it was the only thing I'd ever seen in my life which actually quoted exoskeletons. So
Really?
they were wearing exoskeletons, and they're a modular structure that built onto you. They kind of built onto them
Right.
where they can add things on and take things off.
Yep.
And it's the same principle. There's been many times when I've spoken to other manufacturers, other designers of Exos, and a big question is, and I mean, this is the best way I could coin it. I don't mean it like this, but best way I could coin it is like a utility belt.
Yeah.
If you think of that utility belt, so like the cartoon characters, they were wearing this structure where you could like bolt things to it to build up what it
Yeah.
would be. So the same principle here, and it does make you wonder as to is that going to be a possible way of moving forwards for a donning process where I suppose we talked about this not too long ago about integration and
Yes.
the importance of integration. So if you start to remove the normal utility belt and you add components to it for the worker, for the first responder to add exo pieces on when needed and take them off, surely that's going to be a way that people could really consider moving forwards.
Yeah, I mean, I think that makes perfect sense. I mean, I think again, this to me, the tool versus the PPE kind of resonates a little bit. It's like if you have a tool, you also probably have a toolbox or a utility belt or something to put the tool when you're not using it. So there is a storage space. If you're doing with PPE, or let's just say not even PPE, you're wearing a jacket causes cold in the morning. You can take that jacket off and put it on your chair and whatever, and then put it back on later if you need it.
Yeah.
It's there's a modularity to your clothing and your outfit, and I think you have to go one of those two directions. There's probably other ways you can handle this, but you gotta if you're not gonna be just locked into this thing for the whole day, you got to build a way where you can either store it in your toolbox or you can take it off for periods of time and then put it back on.
Yeah, when needed.
Yep, when
And I
needed.
think I think that doffing process is what's really going to promote that element of adoption.
Yeah.
Because if it is to go in the toolbox and to be put to one side when needed, there's no way anyone's going to put it on if there's a time process to get it on with all the clips and the straps.
Right.
Or as somebody said to me, it's like trying to attach a million straps and you end up looking like a bad porno film from the 70s. You look and go, I'm covered in straps. What's going on?
Yeah, yeah, it's a little bit crazy, right? And
Yeah, exactly.
if you go down the modularity route, it's like there could be, let's say, I'll use some clothing terminology. There could be a base layer that stays on the person all day. It's light, it's flexible, but that base layer is there and it allows for that modular, quick attachment and quick removal type thing.
Hmm.
That's an approach where you can keep a portion of the exoskeleton on all day long, and it makes it easier for the person to decide to use it or not. That's
Yeah.
one way to do that.
I think that's where it gets super exciting because what you end up with is you've got that modular based piece, but I suppose fit becomes a big question, doesn't it?
Yes.
Once you get to that point, if you're gonna have component pieces, you're gonna have to fit somewhere or another. It just makes me think of the stuff that
Yeah.
Tan talks about in O2 for the human factors. If you don't fit, it's not gonna work right.
Right. And the I would argue. I don't know if I can prove this or not. This is going to be a bit of a statement, but I don't know if I can prove it. It sounds right. It's one of those statements that sounds right, but I'd like to have a reservation to withdraw this in the future. So my statement is this: I think the closer the layer is to the skin, the more it has to fit the person well. And my logic behind this is the thing closest to the skin is probably going to be the attachment type mechanism for the exoskeleton. Whereas,
Hmm.
let's just say, you have a powered exoskeleton and you have an actuator. That actuator can be quite a distance away from the skin, and it doesn't have to necessarily fit as well as the thing that's attached to the skin. Now, you can make some arguments in there with alignment and all that, but
Yeah,
but
yeah.
that's a bit different of a beast. So that's my statement for right now, and I think that's something maybe to for us to explore. It's like how close is it to the person's skin, and how well does that actually fit, and how what is the other thing, the technical geekery around that, which is uh, what is the flexibility and the precision that fit has to be? What is the tolerance level of that fit? Can it be a little bit loose, or does it
Yeah.
really need to stay exactly where it is all the time?
So, I mean, earlier I talked about the Marsha structure that we made.
Right.
Now, this at some point I'll get a demo piece. At least you can see it. And Marsha had large actuators, linear actuators,
Mm,
between groupings of spinal segment pieces, and it would push and pull, and then you'd end up with these spinal segments, and that would be attached to the person. So you'd end up with a distance. We figured out that as that moment's growing
right.
as the force is applying, you need to be able to convert that mechanical force into a moment
Moment.
to
Right.
go around that, or else you ended up just pulling away at someone's joints
Right.
because it is, and we'd realized that the distance where the joints are based on the actuation that you're applying to it is vital for how you're converting it to a moment.
Yep.
And it's a really interesting idea because I know my point is I'm just saying that I totally agree of that where it sits relative to the skin given to where everything's sitting is huge. It's
Yeah.
such a huge effect. And arguably, if you get it wrong, you could end up using more power than you ever needed to actually achieve that goal.
Right. Yeah. I mean, it gets down to, the basics of engineering, which is to me is sort of like lever arms, mechanical
Yeah.
advantage. A moment is
Linkages.
a
Yeah.
sort of like a fancy way to do mechanical advantage too, which is, it's force over a distance away from a point. There's some cosines and stuff like that in
Yeah.
there
Yeah.
too,
Yeah.
but
Yeah. Yeah.
in basic, that's kind of what it is. And like you said, that distance from that point, and most of the time we're kind of thinking is like the point's going to be at a joint. That's usually where the actuation is happening. It's across a joint in a person. Um, so that distance from that moment point is kind of crucial for everything.
Yeah. It really is. And when we got that on there, and then we were appreciating about that design piece, that's where we'd realize the fixture
Mm,
to putting onto someone. I say fixture, but
yeah,
the mount
the
points,
mount point. Yeah,
the mount point is huge, and I mean, no one has really ever laid down a roadmap to say what is the best way to mount.
right,
So a lot of people try to use established sciences, as we well know, for climbing harnesses, for example,
right,
right through to the way that a backpack or a race car seat engages with the belt buckle clips.
right,
And it's no one's ever really done it. And I mean, as we know in some of the conversations that we've heard whilst we've been in the O2 side of things, that conversation about how it fits has become such an interesting a point at the minute. But again, all if you can get that fit right, but if you get to the point where you've got too many straps to achieve that fit, the doffing has been destroyed and then adoption is gone.
right, right. And I love the climbing harness thing. That's one of the it's a funny term to me because climbing harnesses, for the most part, don't really help you climb. They're really
But
there.
yeah,
They're really
it's more of a
there
full
to
harness.
stop you from falling.
Yeah,
Maybe there to help you, rest and hang or get a static. And then in certain cases where you are using a mechanical climber on the rope and it's kind of hauling you up, okay, maybe
yeah,
the
yeah.
harness is there, but the harness is really there. It's not really a climbing harness. It's really just a
It's a full
fall
harness. Yeah,
harness. Yeah.
yeah. Yes, bad terminology from myself right there.
No, no, it is the correct terminology. That's what it's called, but it's kind of ironic, and it's like, that's the thing. It's like we have these terms for these things, but the actual usage of it is kind of different. And this is the same thing with the exoskeleton. It's like
Yeah,
the exoskeleton, to me, at the heart of it is it's a mobility device. Yeah, you can have it do a few other things too, but it is about
yeah.
moving in
So
some way or another.
I it's interesting. So I spoke to probably a couple of weeks ago. I spoke to some old friends who were in the rifle. They call it the rifleman battalion
Okay.
in the UK. So I spoke to these guys, and what their task is to move larger RPGs
Okay.
from one position to another position,
Yep.
and basically, basically these guys are just jacked soldiers who move stuff around. So these are big guys.
Yeah.
I
They'd
should
be
say big guys and girls. So
yeah.
some of the women there, you kind of look and go, you would kick my backside.
Oh yeah. I think they're
So
called combat engineers in the US. I think
yeah,
that's a very similar profession.
so when I spoke to them, they told me about a device that they use, and this is a mount device that
Okay.
sits between the webbing and their rucksack or
Yeah.
their mount. So when they're
Hmm.
holstering these large weapons, it sits and it almost acts as like a think of it like a crutch that
Yep.
clips onto the back of the belt.
Yep.
And they said to get it on and off super quick. They said they love the donning and doffing process of this thing. It has a small linkage piece, so technically falls under the term for class exoskeleton.
Nice.
Don't go there. And and but what they were saying is they felt the designers had prioritized too much of doffing.
Mm.
What they've ended up with is just they called it like a crowbar on the back,
Oh yeah.
and they said, look, it's just not. I mean, I'm putting it in a lot more nicer terms than how they described it,
Right.
and they were saying that that process had been focused too much onto that, and they wanted to see exoskeletons try to support some of that for the future, where they're not saying for infantry, so onto they're not talking about the battlefield. They were talking about, if you will, they're talking more about logistics,
Right.
and they're talking about load carriage.
Right.
So load carriage for anybody is just when we're talking about moving of large equipment from stage A to stage B in all different forms.
Right.
And they were really talking about that. But I found it really interesting of that these solutions have been presented out there, but no one likes them, no one uses them, and there's a lot of opinion that's there, and you kind of go, that's the type of stuff that's needed to be known. Where donning and doffing, I get it, it needs to be there, but you can lean too far, too much at one point, and that brings me to the point of could you end up leaning too much to fit?
Yeah. Yeah. Well, to any of these things, overemphasized in a certain area, like the doffing area, I could see, like, in my head, the minute you start describing that, is like, I know what's running through my head is this thing's so easy to doff. I don't have a lot of confidence it's not going to fall off when I really need it and something's going to fall on me. That's what's running through my head when something comes off too easy, you know?
Yeah.
And then, the opposite of that is like, okay, this is going to take me 5 minutes to fiddle with to get it off once I need to do that. I don't want that either. So there's this sweet spot in between those two for all things that attach to a person or anything. And but I like this idea of the exoskeleton providing a better lever type situation for basically a mechanical advantage to
Yeah.
whoever's using it at the time.
And I think that's really where that sweet spot sits. And I think it's like anything. If you lean onto too much trying to solve one thing, something else suffers. And I think there is that Goldilocks
Right.
position,
Right.
and I think that's where it'll end up being. But I think it's fascinating of that. Really, until we get to the Savile Row of exoskeletons, where we can get somebody who walks in and it's fitted individual per person, we're always going to be at that spot of a little bit of fit, a little bit of doffing.
Right. And what I especially around the lift area, I always find it, a little bit funny is like, you know, everybody's focused on, you know, either the shoulders or the back or maybe the legs and all that. And, if you or anybody else has ever moved from one house or moved from one apartment to another, like almost every moving company around the world, not yes, they use their hands, but they also use lifting straps, and they use belts, long belts, to help them handle all of this stuff. And we don't have that really in the exoskeleton world yet. It's still like so focused on the mechanical structure of the person. And we say we do a lot of stuff around load carriage, but we don't do a lot where it's like, hey, we've made it easier for you to lift the thing because we're either eliminating the need for you to use your hands, or we're making it easier for your hands to have greater strength. And that's another area where, okay, we didn't get into this, but that's a key part to donning and doffing. Where are you putting the places where I have to either latch it up? Because I've been in exoskeletons where you have to do this kind of stuff to get things to
Yeah.
actually fit. I'm like, I can't. It's like I can't reach to certain places. I need another person to help me do that. And then if I have to take it off that way too, I'm like, hold on, I can't reach to the thing that snaps it and makes it come out. I'm like, okay, guys, we need to do a little bit better on this, you know?
Yeah, yeah, exactly. Well,
Well, that's awesome, man.
um, yeah, yeah, that's awesome, awesome, and I think it's a key point to continue a little further discussion as we go down the line.
Yes, absolutely. And I'm looking forward, since you're looking at all these issues, if you've got some interesting solutions that everybody should start considering. Because I know we've talked about it in our standards committee about, you know, sort of standardizing around certain kind of buckles and snaps and stuff like that, sort of like they
Yeah.
do in the textile area, because that's a big choice. What are you using all those things?
Yeah, I mean, there's a lot. I mean, moving on to a few more episodes, I think we need to discuss a lot of things: elastics,
Yeah.
offloading, offloading load whilst wearing a soft exoskeleton. Where does all that sit? Does it even work? Don't
Mm.
get me wrong. I
Oh,
know everybody will.
you're gonna stir the hornet's nest, aren't you?
Yeah. Yeah, I know the passive offers that support, but does it offload? So yeah, I'll save that for another day.
Oh, well, I can tell you the load goes somewhere, so, let's
Oh yeah,
let's save that secret for another day.
definitely. Awesome.
Alright, take care before we get in trouble.
Yeah, 100%. Yeah, get off quick.